Well, thank you all for being here today. My name is Meg Wolf. I am with the Idaho Water Resources Research Institute here at the University of Idaho. My background is in hydrology and water resources. And I'm really excited to talk to you all about our 2025 Baywatcher season. I'm going to have Woody start off today, and then, but just want to start with special thanks to all of you for being here, for participating in this program. We're going to run it a little bit differently. It'll be a pretty quick meeting this year, and then hopefully some time for questions and interaction with some of our data. We've made a couple of big steps on trying to make our data more available and publicly available, and then also available for you all to, as you all have backgrounds in engineering and water resources and data science, if you want to start making figures or looking at trends over time, we're hoping to give you that opportunity as well. I guess, Woody, do you want to take the first couple and then we'll go over the data all together in the report, and then we'll go over questions.
Cool. Thanks.
Yeah, thanks.
All right. So goals. I appreciate all y'all being here and support from all of our citizen scientists and volunteers. And so our goals are, like it says here, and can we get rid of the window?
Yeah.
Okay. That detect signs of any kind of nutrient problems, increase in the lake, that kind of thing, to identify those trends in lake water quality, and also to get folks involved and aware of the issues that Coeur d'Alene Lake has, and to be present in that conversation, right? To have conversation with folks and to make sure that the community as a whole kind of knows that, right? And then really working with DEQ, working with the Coeur d'Alene tribe, other interested parties in the community to be able to make sure that Lake Coeur d'Alene is a healthy place for people to recreate, for people to enjoy, and for it to be here for a long, long time, like it has been, right? In a good place. Cool. Thank you to everybody that participated, that is on the lake. So Susan and Bob, thanks for being here, for being a part of that. David and Bruce weren't able to make it, and or Barb and Bob, Joe and Lynn, Julie, thank you for being here. Steve, thanks for making it, and Chris Kellogg. This year, this summer, we lost this sailboat, this lovely sailboat that I got to go out and be behind the wheel of. That boat was sold, and that was our boat at Panhandle Yacht Club. So if you know anybody that has a boat at Panhandle Yacht Club that would be interested in being a Baywatcher, I reached out to the harbor master there to try to make some connections with the yacht club. We did talk to some boat owners there the last day we did monitoring in October to kind of, and I gave that person my card to see if he'd be interested in taking over as a Baywatcher there, but that is something that we're looking for. So. And then thanks to our volunteers that went out on the boat with me. Bobby Myers, he is a U of I alumni and went out with me once. Jan and Kiara work here. Bethany Lemon was Jim Eakin's intern for the summer. Jay, thank you for being here. Did any of our Baywatchers not meet Jay? Did you guys meet Jay? Mm-hmm. Okay, cool. Roman is on the board for Kootenai Environmental Alliance. Was out with me a few times. Jennifer Haas is one of our TCP teachers at Coeur d'Alene High School. And Vicki Campbell, she volunteers with several different organizations in the community and works part-time at NIC, retired full-time from NIC this past October and was able to go out with me. Luke, thank you for being here. Luke, you're just finishing up your dissertation. Yeah. So Luke reached out to us here at the IWRRI and went out on the boat with me a couple of times. Appreciate that. And Lindsay and Craig got to go out with me, and that was a great time. Really enjoyed having you out on the boat with me. So thanks. Thank you. Our monitoring methods. So you all have a hobo sensor that we get temperature readings off of, and then we do our monthly profile monitoring where we check these aspects of the water quality and at each meter. So and our SECI readings. So. All right, Meg, I'll let you take it over.
Okay, well, thank you. A little bit of context. I pulled a couple of figures from our last year's PowerPoint. I don't want to spend too much time on this. I think last year I went pretty in depth on the long history of monitoring on the lake, some of the regional studies that have been completed that put some of the challenges that the lake focuses into context. So I just want to acknowledge that one of the key impacts of climate change that we are identifying and impacts on the lake is rising temperatures. Ambient air temperature is often our metric for that. So we are also monitoring surface water temperature over time, and we'll look at a couple of those trends as well. Another thing to remember in our data synthesis and our data context is a lot of the data that we have for ambient air temperature or other data points, they go back for a long time so that you can look at trends over time. So this figure, for example, goes back until the 1890s, and we can look at historical patterns or trends over time. Our monitoring program goes back until 2019, which is a great place to start. But something to remember on if we're looking at long-term variability or trends over time, we often need a long period of record. So we can just remember that. The other thing why we monitor in Coeur d'Alene Lake is due to the very unique history and legacy mine impacts that mining operations in the headwaters have severely impacted downstream water quality and downstream water availability, something to keep in mind as we discuss the challenges associated with Coeur d'Alene Lake. The sediment flowing out of the Coeur d'Alene River is what is transporting impacted waters or impacted sediments from upstream in the headwaters down into the lake basin. There's been a lot of work and a lot of great study associated with the main part of the lake, the impacts that the floodplain has had on the main body of the lake. And a lot of that work has looked at metal loading, analysis of the sediments and the deeper layers of the lake, and then also water quality monitoring in the main part of the lake. So as Bay Watchers, we are not focused on the center part of the lake, but a little bit more on the outer reaches or the regional bays. And I just put a couple of these figures in from last year. These are from Craig, with essentially just showing that lead is present in sediments at the C1 site with relatively low metal contaminants in the water column. And that is ideal. With the water quality is less impacted in the water column, but more impacted in the sediments, or those contaminants are capped essentially by that dissolved oxygen cap. Last year, I talked a little bit about changes in the headwater. I don't know if you guys were all here last year. This video essentially shows the long-term changes of Land use cover, we're using satellite imagery, so the potential impacts from deforestation and land use change in the headwaters and the impacts on sedimentation and potentially nutrient loading that could occur. And we could probably revisit this if we're interested, but I just wanted to revisit that this part of the watershed from 1985 until 2024 has been significantly deforested due to logging operations. So one thing that we are always talking about with all water bodies in the Northwest and kind of across the US is this concept of nutrient loading, or or the term eutrophication. So just a quick revisit on why we are thinking about nutrients, the excess of growth or algae blooms as a concern, and how that can impact dissolved oxygen and cascade down into the impacts specific to Coeur d'Alene Lake, which are those potential release of metals from the sediment bottom. So eutrophication is the all-encompassing term that results from excess nutrients, such as phosphorus or nitrogen, which enter lakes from varying runoff sources. So a couple of those places I identified before, but they can be point source pollution or non-point source pollution is the primary contributor to nutrients in the watershed. When you add fertilizer to an environment, things like to grow. So algae production increases when nutrients are more available. And then what happens when algae overproduce and they fall to the bottom of the lake, they're then decomposed by an anaerobic microbial process, which takes up oxygen. So that consumption of oxygen by decomposition of algae can lead to low oxygen or anoxic conditions. And low oxygen conditions can lead to or allow for metals that are bound to sediments to be released into the water column. So we talk about the oxygen cap, or the high oxygen environment that is positive for keeping metals within the sediment. This is just maybe a little bit of a visual for that process. And one thing I would love as we go through this has taken me quite a lot of time to try to think about how we describe this in a really simple way. And perhaps I just took, 4 minutes to describe that. But what are some approaches out into the community? You guys are all very well versed in water quality. You know what eutrophication is, or you've heard the word before, or you have heard of the oxygen cap. And one thing that I think out in the broader community, it's a pretty big concept to try to explain. So if you all have either feedback or ideas for figures or ideas on how we can think about this story, I am very open to feedback there. We can go, okay, so that's kind of the background. And then I go into a little bit of why we monitor at the different levels. Perhaps we can open it up for discussion on this process right here really quickly before I jump into data.
I think one thing that would be helpful for a lot of lay people is, what is it about a no oxygen anaerobic digestion that creates the effervescence that boils up the metals? If you had some quick way of describing that, people could understand why it's important to keep the oxygen levels high.
So do you think that just this figure here,
right,
essentially of
right in there, what is it about anaerobic digestion that causes the eruption of the metals out of the sediment? Is it a percolating effect? Is it what is it?
You want me to?
Yeah, jump in here, Craig.
With that for a long
This-
I have the biochemistry
I'm
now.
Craig.
Right.
It is an incredibly hard thing to make simple. And I actually have some graphs that I thought helped, and I can share those with you at some point in time. So what happens is in the sediments, all the metals associated with the sediments, they're bound onto it. And they're bound onto it in two ways. One of them, I just thought of that word, is it's stuck on the surface. And with that, if you change the acidity, you drop the acidity, it changes the surface so the metals pop off. Kind of like when you dissolve things in acid. Then when your oxygen starts to go down, bacteria actually eat the iron oxide mineral, they eat the mineral structure, the crystals. And so the metals that are inside here, like my water, once it's eaten down, they would come. So it's a two-step process that associated with how oxygen and bacteria and metals pop the minerals and sediments. And that's as fast and as short as I can.
I think that one of the things I wonder, Greg, is there a more relatable analogy, like the process of kombucha, or I don't know, like that you can tie it back to where people can actually get like, oh, it works like this, and use that to help people understand.
Let me think about that. Maybe breaking an Easter egg. I don't know.
Yeah, I mean, I think that
Cracking
would
egg.
be, yeah, something like that would, I think, be helpful for the average person to be like, oh, okay, this is good.
Or like the release of, so I think this like concept of acidity and like you said, dissolve things in acid. I
Right.
think that is a, like you said, a really complex biogeochemical process. Something that so I went to the dentist the other day and the dentist was explaining to me why coffee stains my teeth. And he explained it in such like a chemically structured way that it was like, as you drink high acidic coffee, it decouples the spaces in your teeth bonds so then it can infiltrate in. So it's a little bit of like this chicken and egg of you have to have a good example that's a different example than the sediment bonding. And maybe this is something we can like think of a figure as a whole of like this process. And perhaps it's maybe not even the process that's that important. It's that when there's oxygen, the metals stay bonded. And when there's no oxygen, a lot of things are happening. Acidity is changing, the capacity, like the structure for the sediments,
Minerals themselves change,
right?
which is hard.
I think what you just said is good from the standpoint of the process can be so complex that people forget the bottom line. So really focusing on the bottom line that in low oxygen conditions, the metals are going to get released back into the environment. And that's more important for people. That's most important for people to remember than explaining the mechanics is good. But if they only take one thing away, you want them to take that away. And just maybe a bemusing thing is that I actually theoretically understand this kind of stuff, but eutrophication in and of itself, that word is, oh shoot, what was that again? And so it gets intimidating, I think. And so I like your idea of getting it down to something that people can relate to, but always keeping focus on the bottom line message.
Is there a better word than eutrophication that you can use?
Oh, good.
The progenic pressures.
And we usually say cultural eutrophication, because all lakes are gonna eventually become eutrophied. It's just a matter of how much influence we as humans have.
It's, you could say humans fertilizing the lake,
Yeah, I mean, fertilizer is definitely,
right? I mean, it's really hard to say. Frank might have a better way than,
Frank, you just got shouted out.
he does this a lot.
Yeah.
Yeah.
Yeah, I'm trying to find my controls here. Sorry, slipped off the bottom of the screen a bit. I don't know, I think on the redox end of things, just put it into the redox concept, right? So that you have reduction oxidation. Oxygen is present, you have oxidation, everything is good. The things are bound up. When you lose the oxygen, it becomes reduced. You change the chemistry and it no longer binds and the material is released into the water column. Probably keep it as simple as possible. I shy away from going into the acid balance and all of that fancy stuff.
Cool. So everything's clear as mud, right? We're all on the same page. So this is something I've been thinking about of like, maybe that's a figure I could email to you all as feedback, like something that and it depends on the audience. I think that's always a question too, is who's our audience? Is it a school aged audience? Is it for our high schoolers in our Confluence project? Is it for
In the 8th grade, we just wanted to get to cross the 8th grade level
the 8th grade is the goal? Yeah.
for journal.
Yeah, if it's like out in the community. So if we do have question or like if we want to revisit this too, I can always send it out and say, hey, what do you think about this figure and this process? Okay. This is not the right thing. This is the right thing. So why we monitor for temperature? We can look at temperature trends over time and either the surface or depth, but then also we're looking for these thermoclines, so this lake stratification that changes throughout the season, right? In our early spring, when runoff is flowing in, the lake is relatively uniform throughout its temperature profile. And then as the summer sun heats up, we get a lot more solar radiation coming in at the surface. So there's an increase in temperature. And then as we go down in our water column, the lower, deeper waters are much cooler and they stay cool throughout the year, except for in some places and in some bays. This kind of goes into each of the stratified layers, the epilumnium, the metalimnium, and the hypolimnium. And where this stratification changes, this does change a little bit throughout the season. And that's why we sample over multiple months. We monitor for dissolved oxygen, like we mentioned, it drives the biology and the chemistry of lakes. We just talked about this. All life needs oxygen, so both for biological aspects, but then also for this release or this positive cycle of low oxygen environments, releasing nutrients and metals. SECI is our measure of transparency in the water column. It indicates how deep in the water column plants can photosynthesize. So there's the photic zone or the aphotic zone. And we have both the view tube and without the view tube, so that just gives us a little bit of a range. And then also the SECI can be used to indicate trophic state and trophic state boundaries. So this figure just shows a little bit of like what an oligotrophic lake is that has almost no growth versus a eutrophic, so or a high growth. This would be more of a pond or a high algae environment. So looking at some of our data for our 2025 water year, I just pulled the April SNOTEL. So for the Spokane River Basin, which we are in here, average snowpack last year, but we had a really, really warm spring and relatively hot summer. There was a lot of wind this last summer though. So I'm curious what it felt like it wasn't as hot as the summer before, but I think it was just as hot. It was just had a lot more wind, and that's what I noticed a lot of. And then in general for the water year itself, we had kind of average snowpacks, a really warm, dry spring, and then average runoff kind of throughout the basin. This is from the HOBO sensors. So for Cave Bay, Cottonwood Bay, and the Spokane River, you'll notice the Spokane River sites just a little bit warmer than the deeper mid-lake sites. And then notice that this Cave Bay at 9 meters, so that one's a lot deeper down. It gets a lot more of that diurnal temperature variability. So that 9 meter level sees a lot more of those cooler temperatures from day to night, whereas the surface stays a little bit more uniform. And we noticed that we started in May, into June and into July, and then we have our taper down into October. We had a pretty mild October though, and it didn't. So I think some years we do drop a little bit cooler, a little bit earlier. We talked about thermoclines, so we can look at our 2025 data. So I just chose one. All of these figures I just did. In the previous years, I've showed you every single year. But I think we have too much data now to put all the years and all the months on one plot. So I just did 2025 data. So when we're looking at these, just to review, we have depth on our y-axis and temperature in degrees Celsius on our x-axis. Each of the different colored lines are each month. So red across all the board is June, yellow is July, August is green, and September is blue. Interestingly, here we have July, August, and September have almost the exact same temperature throughout all 3 months. We didn't get that cool off in September. We did have those couple of really warm weeks at the beginning of September. So sometimes at some years we see that temperature for September dropping back down to where it was in June. We didn't see that here. And then you can see a little bit remnant of in our June sample here, we have less of that defined layer. As you remember, spring still has a lot of that runoff. There's a lot more mixing that's happening in the lake. So there's less of a stratified thermocline as we have in the later months. And in some years, we do sample in October and it kind of, that starts to then go away as well when the lake starts to turn over. So that's something to look at. This is our dissolved oxygen, same for Cottonwood Bay. Again, with dissolved oxygen, we're looking for concerning levels of low oxygen. So we're looking either for essentially a below a 6 or less would be the concerning level of oxygen. As you can see throughout the profile, it's relatively in the green, as we say. Another note for our 2025 data, our pH sensor seems to be a little finicky. So we are looking at replacing our pH sensor. So moving forward, just to make a note on all of our pH data for 2025, we're going to put an asterisk next to that. These two data points are from August of 2021, July of 2024. And you can see, I think the biggest thing to note is that there's a little bit of variability within the profile, and all of our data for almost all of the sites, if you take a look, our pH data doesn't have a lot of variability. So I think it's losing its sensitivity, essentially. So there's like not a lot of sensitivity. I would expect that this is pretty uniform throughout. So we are going to look at replacing our pH sensor, just as a note. And then, yeah, so we can go through. So I started from north to south. These are now, we're now up to speed on our Baywatchers report here.
And on the pH before you go away from it, it's kind of interesting though when you flip through it real quick. Like most of the bays do have that consistency, and I look at mine, and every single month it was bouncing around.
So yours did have the little variability.
I think if that's the right graph, because it might be labeled.
Yeah, perhaps we have a mislabel, but yeah, almost all of them are pretty consistent.
Yeah.
And then Julie, which is yours?
Rockford. And I think it's supposed to be the second graph, and every single month it's bouncing like that.
Interesting. Okay, well maybe let's take a look at that. Rockford, the second one. Oh yeah, we put 2 dissolved oxygen in. That's why you have a double.
Not in there.
Yeah.
Okay.
Yeah. I didn't check that on my QA/QC. So yeah, you have. We will update that one for you. And I might have done it on the PowerPoint, and I just copied and pasted it weird into the to the publisher. But thank you for pointing that out. I'm gonna make a note of that. This needs a new pH. Okay. Susan and Bob, here's your profile. So one thing to note on your Secchi, because you're so shallow, we don't do the Secchi disc with YouTube.
Yeah.
Because you can see the bottom of the river, so we just do depth. And then you also had standardized pH, so we're gonna put asterisks over these. We did have a little bit of a temperature profile here. And then in your August sample, it was all uniform. And then a little bit of a dissolved oxygen trend, but all within that green oxygen range of above 8. Steamboat Point, we do have enough data for both Secchi depth with the view tube and without the view tube. It looks like we are missing one point, but the one thing to look at for Secchi is this is probably, I was really debating on if we want to go inverted on this. So all of these are inverted, like as if you were looking down into the water column. But this one is the higher Secchi depth, the more clear it is. So if you're thinking about clarity being a good indicator or higher numbers, I did leave this in a positive form. So this is like, if it was from 0 to 2, this would be poor visibility or you couldn't see very much. Whereas this 6 to 12 range or this like 12 point here is like really high clarity. So good visibility down into the water depth. Our temperature, the nice thing about these deeper sites is that we do have those really defined thermoclines. And then the oxygen is often inversely related where colder temperatures, there's higher oxygen levels. And Craig, I did just you, I only put the dissolved oxygen in milligrams per liter here, but in the report, I also included it in percent as you suggested. So just so that you're all aware, so in this report, we have both dissolved oxygen in milligrams per liter and then also in percent saturation, depending on your flavor of interest. So Panhandle Yacht Club, very similar. So one thing I noticed is really relatively high clarity throughout the 2025 Secchi depth across a lot of our sites. I think we did have a pretty windy summer, so there was a lot of like turnover throughout those bays, and there wasn't a lot of chance for things to kind of filter in and settle. That is my thought. There might be other things happening as well. The temperature profile is really quite good on our Panhandle Yacht Club. A little bit warmer at the surface in July than we had in August, and then it did start to cool down. Notice we did some of those earlier sites we sampled earlier in September, so that's September 10th, and then by September 24th, we're dropping down. It started getting a little bit cooler later in September, so that's another thing to note. Depending on what day of the month that we're sampling, does have a little impact in the variability. Dissolved oxygen, I'm suspect of this value here, but I left it in as a note to take a look at it. And then the rest of the values are all within that 7 to 10 range. Butte Bay, again, pH, very interesting. Our temperature profiles are a little bit higher in where that transition zone is. So I think maybe that's just a little different part of the lake than the other deeper sections. And then our dissolved oxygen is still good in that 9 to 12 range. Blue Creek Bay, a little bit shallower site, so we have less of that thermocline visible, but there is a little bit of it in the early sites. So in our June sample, we have it, and then later in the year, the whole water column is pretty uniform throughout. Dissolved oxygen also then follows that trend of inversely related. Bleeding Pine Point, Kind of the same story. We have this late September sample that did start to cool off again. And then our dissolved oxygen is all in range. And again, the Secchi depth did spike a little bit. Oh, my dates got all messed up on that one. But our later September sample was really relatively high and clear. Rockford Bay. So here's your pH up here. That's accurate. I didn't pull it in. But see, this one's interesting because it like our June. So this one might have been one of our early samples. And anyway, I think what we'll probably need to do this year is go out with another pH probe and do a little double checking. We do QA/QC them, and like we go through all the protocols at the beginning of the year and kind of throughout the year, but we just need to make sure that the sensor itself is not faulty. And then, yeah, our July, so this would be interesting on the Rockford Bay, is down at that 12 to 13 meter. It's almost fully uniform in July. So either it was pretty well mixed. I don't know if it mixed all the way down, but it's just quite warm throughout the whole profile there. And then dissolved oxygen was all relatively fine. Deep Bay, same thing, right in this 10 to 12 meter. There, it is still cooler, which is interesting compared to just a little bit around the corner of Rockford Bay. And then dissolved oxygen is good. Really high clarity in the later dates, which is also indicating that I need to fix my labels on these ones. And two, the later September dates had high Secchi depth. Cottonwood Bay, same a little bit of the story. We have relatively clear and high Secchi depth in most of the season, and then nothing jumping out for dissolved oxygen. Carlo Point, similar story, a little bit shallower profile, and relatively warm on this one. And then our dissolved oxygen, I swapped these on this one. This one is probably this late September value is a little bit of a concern, as it's dropping off in the lower levels. The August and July samples are starting to drop off a little bit, but not as much as the late September, or I guess mid-September sample. So I did start a little bit of now that we have about 6 years of data, we can start to look at these in trends over time. The thing that we have to address or associate with is we sample seasonally, right? We go June through October, and then we have a gap, right? So if we're going 2019 season, then there's a gap, and then we restart. So there is a little bit of this variability, right? Where we have our June is low. So we can start here. So looks like we did a little sporadic sampling in 2021, and then in 2022 we really started. We have our June, July, August, and then September starts to drop off again, and then we repeat June, July, August, September. One thing on our data and like processing these data is we have 11 sites, and then we have almost complete samples for each of those 4 months. Sometimes we have, for some reason, or we missed a September sample, or we sampled on August 31st instead of September 1st. And so it's the way that we can process these is probably a little bit different for each individual site. So we can like think about how we want to present that. But the one thing I would note is, in general, like I mentioned with all trend analysis, we don't have a century-long data record to look at these over time. But as we continue to monitor, we will start to be able to pick out variability or trends in our data. So this one is 0 is at the surface, 5 is 5 meters down, 10 is 10 meters down, 15 meters, and 19 meters. And you can look at our, surface temperature trends over time. The 10-meter depth at Steamboat is like relatively tracking with the surface. But over here in Beauty Bay, that 10-meter depth has like a little bit more variability. So Beauty Bay just has maybe a little bit more of that thermocline occurring for longer parts of the year. Moral of the story, no significant trends up or down as far as the data that we have, which is good to continue to monitor. Okay, so this is an exciting new addition. I have put this year, you might have noticed, we entered all of your data points into a tablet when we were out in the field rather than to a data sheet. And I made them all publicly available to you on this Google Drive. So I will send you all this link. It looks like you don't all have your computers here. If you were students, I would say, everybody get out your computer and we'll click on this link. So this is just a copy of them so that we have the hard files, so that if for some reason you go in there and you delete all of your data, we still have it somewhere else. So now the 2025 data, you guys all have access to this, and I will share that via the email that was sent out by Lindsay. And then the other cool, exciting thing that we have started to do is to host our data on a web platform. And I'm going to start this by saying we need your help. So this was a really big project that Jim was very helpful with, and Jay was very helpful with on our data synthesis and kind of bringing all this together. This is now a platform. So the IDA H2O is a water quality data portal that we can upload data to, and then we added some features to the data portal to make these plots that I create every year at about this time. So hopefully this can be a little bit more real time as we go forward into the future, so that after we enter our data next June, we can put it into the portal, and then it'll plot these figures for the entire time series that we have, and we can visualize the data in a little more real time rather than in January for our June data, which we recognize it just takes time to get to this point. So I can show you all how to do this if you're willing. Actually, maybe before we do this, let's revisit our data that we've already visited, and then if we have any questions on these, and then I'll show you how to upload your data to the web portal. Does that sound good? Okay, everything's clear as mud. Any questions?
I'll ask one question. Since I still haven't recovered my temperature sensor that's on my dock that disappeared. So is the temperatures that you're putting into this package the ones that are coming off the probe that we do in the middle of the bay? What's happening with the temperature data that's coming from the
HOVO sensor? Yeah. So this is the HOVO sensor data.
Okay.
So this is the
just all consolidated.
Every single day. Yeah, it's just for each of the sites. And what I could do is I could pull them into individual, like for each specific site, but I just put them all on one. And this is 15-minute interval data, which we then aggregate. I just plotted this. This is just 15-minute interval over time. But we could aggregate it to daily or diurnally, so like morning and night, or daytime and nighttime. And this, I can also make this data publicly available on that Google Drive if we're interested, because essentially when you pull that data sensor, it goes into a program that we use to portal it, and then we turn it into a CSV, and then it's just a long list of dates and a long list of dates here, and then the associated temperature as well. And we have that for multiple years. So, okay. Yeah. Okay. We'll go through this really quick if you are all willing, and if you are technically inclined, I highly recommend. Okay, can you guys see that? So this is, I guess, Jim is here. Thanks to Jim, we have now a place to put all of our data. And so there's a couple different ways we can do this. You can create your own login, which then Jim approves. Or for the sake of today, we also have a Baywatchers login. So our username as a whole is Baywatchers. And if you want to use, you can use either this or you can create your own. And then our password is IWRRI, IWRRI.
I might have, you might have to email me, I might have to set up, just give me a, password or something you like to use.
Or like Rockford #1.
Yeah. You may be able to do it yourself. I'm just used to doing it for my volunteers.
Okay, so for this, the broader group though, if you don't want an individual one, or you can do an individual one with Jim, is you can do Baywatchers. Apparently not a capital B, it's a lowercase b. I didn't think it was case sensitive, but it is. And then what's exciting is we can either look at the data that's already been added, which to be honest, I haven't added very much, or we can manage data. So if we go in, it's on this back sheet here, we have a little bit of a directions. You can go to this website, and that's the link I just clicked. The Northwest Knowledge Network is the NKN, so it's part of the UIdaho server, but IDA-H2O is the host. There's the data information there. And then if you go to each of these sites, so number 1, it says go to manage data, and then we scroll down to add a standing water assessment data. So a lake is standing water. And then we have all of these nice sites that Jim has been adding in over many, many years. And we're going to zoom into our.
You can just scroll, I think you can just scroll down.
Oh.
Past
Okay.
the map. The map shows it first.
Oh, okay.
And you can just start, yeah, you
You
don't
can
even
start
have
here.
to click on the map, but the map shows you where everything is.
The map is nice because one way to get to this, thanks to Jay, which was very helpful. They added in all of your sites already. So we can click on Steamboat Point or Panhandle Yacht Club or Beauty Bay, and then we can add in a data point. So the way to do this in real time would be to say like, okay, it's January 20th and I am collecting us data. You guys all know the process. We add our site description in. We can go through a little bit of the metadata that we collect. But then what's really exciting is you can enter all of the data that we collect in real time, or because we have data already collected, for example, we have Carey Bay here from our June sample. This is the data that is here. So we can copy this Carey Bay data after we entered it into the Google Sheet. And you can go paste entries from spreadsheet. This is a very fun tool that will fill this out. My example, oh no. Oh, I didn't add, okay. So 1, you have to change it to Celsius. Wow, I really thought I was gonna show you all some magic. Okay, let's double check our directions. So it says, paste entries from spreadsheet. So we do want the depth column. So it has columns depth included. So when I copied it, I didn't include this depth column. So we want 0 through 12 in our whole column. We'll copy and paste and then fill our depth assessment. And there is all of our water temperature data, our dissolved oxygen, both terms, specific conductance and pH. This one, so I'm not going to go through, I could go through all these. You have to fill every checkbox for it to submit data or it will get mad at you. But for the sake of our example, I did a couple of these already. So if we go to visualize plots, now this is, once you enter your data, it will automatically plot it for you in this nice depth profile, which is very exciting. So as we go through this process moving forward, you can then select your parameter and look at your June 2025. So in June 13th, we sampled Rockford Bay. I added this in yesterday, so it is ready to roll. And you can look at these over time. Alternatively, so this is in our Explore Data tab, you can graph it as a time series or a depth profile. So you can also graph, as we add more data in, all of these plots over time. So unfortunately, we don't have a significant amount of data points. So our Rockford Bay air temp, we could go water temperature, we added that, and we have one data point in June.
The only data we would have is just the SECI data.
Except for when you go sample with us, and then I send you the email that has all of the data that you collect. So that it's just if you're interested in looking at the data that you collect with Woody out on the boat, after we get back to the lab, we can put it on the website and it'll be available for you to look at if you're interested.
So I think what he's saying, as far as what you want us to do to enter in, is just our SEC data. Is that right?
So the SECI data that we collect from, I guess that's a good question, because there's a higher frequency of SECI data than just the monthly samples.
Okay.
So that would be a good point on where to put that in on this, because this is set up to like do the full, like I said, it'll get mad at you if you don't add all of the parameters. So let's say, for example, you take a SECI depth on June 1st, but we didn't come and do a profile until June 13th. We still want to add that data in. So that is a good point.
There's a way you can make those non-mandatory.
Okay.
I think if you go up to the top of the form and if there should be, okay, for the, not the standing water data, okay, so not the map, go below the map, let's scroll below the map. Is there a thing that said, no, it's not on, is there a, so on the stream data that we collect, we have a selection that says, was the stream unsafe to wade in, or was it too dry to take data? And if you select yes, it was unsafe, then nothing is mandatory. You can still pick and choose.
So we
could probably add that, if like a little thing that says SECI disk only.
Yeah,
like that.
so you could put in a date and then your metadata for that date, and then just add SECI depth without adding in the rest of the parameters.
Yeah, well, because we're reading from a completely different location than what the.
Yeah.
Yeah.
It'd be like a different site, but then that could be plotted over time too, which would be great. Cool.
We can work on that. We work very closely with the app developer. So this is stored all in and it was built by the people that do a lot of the university's research data. And they securely store it to federal standards, National Science Foundation, National Institutes of Health, data security standards and all of that, blah, blah, blah. But the app developer is very attentive to us. So we can work with them. I'll be able to find a little bits. I've got a little bit of funding for that too. We can work to make it easy.
Yeah, and the hope is that we will still continue to do this like every year. We're not trying to like put it all out to you guys, but we just want to, if you're interested in looking at your data, and if you want to put it into Excel and make these plots in Excel or in R or in Python, you're welcome to do that also. But if you want a way to visualize the data that's kind of like real time, then this is a way that we're trying to make it available.
Being a senior citizen, it would be helpful if none of this is in any of the handout. So trying to remember How to get in, how to log in,
It is on the last page.
okay.
So on the data availability one, this one is on page 30. There's a little bit of the website, and that you can either type in, or I can also email it to you, so you can just click on the link. And then a 1, 2, 3, and we can also kind of walk it through again if we need to.
You should mention that all of these data are publicly available. You don't need a login to look at the map I don't know what you need to do plots.
You need a login to
You need a login.
enter data,
To enter it.
but to look at the data and see all the plots, then anybody can view them.
You just go to the website, click on the map, basically.
And then as you can tell, we have all the data kind of in our internal systems right now, and that we haven't moved it over, at least our historical data. But I am hoping to get some a little bit of time and or additional time from undergraduates or graduate students or interns that might be interested in uploading historical data. So I think moving forward, it'll be a little bit easier to visualize future data, but it's the 2019 to 2024 data that we will work on integrating into this portal so that it's out and available to see. Okay. We're still kind of early, but if we have questions or other concerns, we can also talk about next season. And I might have, if we have any questions, and then before we wrap up, I'm gonna have Lindsay come up, but any questions on data?
Let's have a comment, and that is the temperature data is really fascinating.
Hmm.
Oh.
Yeah, and I'm still processing it, but it's potential for it to show some of the mixing we might see in the lake. So I don't want to go too far, but it's really fascinating to see some of that time trend to Cave Bay, and how deep down that goes.
On these ones?
Yeah, and some of the plots are interesting too. It's hard to visualize it in my head, but
Yeah, hopefully we can. These ones?
no,
Oh,
the hobo,
the hobo sensor, yeah.
where that 9-meter one dives down so cold. So
Yeah.
much more than the surface one. Says something cool's going on there.
Cool.
Just not sure quite yet.
Well, I'll send you the data, Craig. How's that?
Windstorms and that sort of thing. I wonder if you could correlate that with
Yeah.
metric data, on what was happening, because you can get quite a bit of turnover if you've got wave action and that sort of thing.
Or
Could
is
be
that,
uploaded.
what do you would know? Is that site, is that down in the kind of the marina? Where there's a lot
Yeah.
of activity,
Yep.
plus the boat traffic,
Mhm.
that might mix it up
Yeah.
more.
Yeah, those weekend dates,
Mhm. Yeah,
Yeah,
right.
yeah.
but certainly wind speeds or data there would be a good correlation to look at to see if there's maybe some alcohol.
Yeah.
So it's just the temperature data has got some potential uses that I'm just beginning to ponder.
Cool. That's promising or helpful.
Yeah.
Glad to hear it.
Meg, do you want to mention anything about the Small Lakes group that's been meeting and kind of what they're working towards?
Yeah. Yeah, Coeur d'Alene's kind of in this a unique, you guys all in the bays on Coeur d'Alene have unique attributes that are challenges to your own bay or and then the lake as a whole. And we've had a lot of the smaller lakes in the region reach out in kind of a broad sense of there's a lot of challenges that are similar across lakes, that it would be great to get ideas and conversation going together as a coalition. And so there is some work being done to get together as a group of a small lakes association. And the question would be, would the Bay Watchers as smaller entities on Lake Coeur d'Alene be interested in participating in a discussion that's related to the challenges that a lot of the smaller lakes in the region are facing? And I wasn't sure because I think Bay Watchers or Coeur d'Alene Lake has it's a big lake, but with little lake challenges also. I don't know, is that?
Yeah.
Yeah, so if you're interested in being on, invited to kind of an initial small lakes collaborative meeting and discussing some of the opportunities for engagement there with the other lakes around the region. I can forward you all the email invite as well.
We had been several years ago, when we were doing the wake boat, wake issues kind of thing, we got contacted by a couple of the bays on the lake because they were seeing similar kind of issues and the small waterways group is looking at a broader suite of concerns, invasive species, et cetera, et cetera. But boat wakes are a part of that, and so we wanted to make sure that if there were bays that were sharing some of those kind of concerns, that might not be seen in the main lake proper, that we could open it up to the bays being included in this group